Alright, so when we think about volcanoes, there's three major types of volcanoes. So what I want you guys to do, I want you to look at these three images. And I want you to find their similarities and their differences. So take a couple minutes with your partners. Just do a little bit of discovery here. Talk about how are they similar, how are all three the same, how are all three different. Okay, and I want you guys to do that for 2 minutes, and then we'll come back and share as a group. What do they all have in common? Yes, they're all volcanoes. Good. Besides that.
They're all outside.
Yes, they're all outside. That's very evident.
Tanner had a good one in the middle.
Tanner?
It looks like it's like, I don't know, it looks like it's sunken a little bit because it's just, it doesn't, I don't know, it's kind of a wide one.
Yeah, okay, it's kind of wide, very short.
Yeah.
All right, that's really important, so let's write that one down. So that tends to be wide and very short.
They're all.
Okay, what else can you guys tell me? What else do all three of them have in common?
They're all.
Think about their general shape.
They're all pointed.
Triangle.
They're all cone shaped.
Yes.
Okay, that's worth mentioning. So volcanoes tend to be cone shaped. Okay. And why do we call them volcanoes? Because they erupt. And they're fueled by magma. Okay, so that's kind of the thing they all have in common. Now, their differences are quite striking. When you look at this one on the far left, how does that slope compare to the slope of this volcano?
It's more of like a hill compared to the other.
Yeah, so these tend to be broad, very wide, and with a gentle slope. And that's also because of the type of magma. Each one of these has a very different type of magma that erupts. And so we think about the first one there, it's called a shield volcano. And in shield volcanoes, like we already said, they have broad, gentle, sloping sides. So these are very wide. Okay, what would be a perfect example of a shield volcano?
The long ones.
No.
Woods.
What would be a good example of this? Where can we see a shield volcano today?
Yellowstone?
No?
They like
Should know.
out right here and
St. Helens? No, that's pretty.
Washington.
Okay, let's get some more hints then.
Hawaii.
Yes, it is Hawaii. So when we think about shield volcanoes, they typically are very circular in their bases, and they're very non-explosive, okay? Very gentle eruptions. Now, this doesn't mean that, hey, let's go camp out at the crater and watch it erupt. You still don't want to be that close, but you can get in fairly close to these. And a perfect example would be the Hawaiian Islands. And what's really neat about that is if you ever visit Hawaii, you can actually take tours up on the volcano while it's erupting. So it's a very gentle eruption.
How does vegetation grow on the igneous rocks after it cools down?
Usually what happens is the wind takes over and you get pollen or seeds and they get dropped into the cracks within the rock, and basically what happens there. The soil is from the weathering of those igneous rocks. As they break down, it gives you soil. And so it's a very long process. So main thing I want you guys also to know about shield volcanoes is that it is basaltic magma. So what does it tell you about the silica content?
Low.
Very low silica.
So it's very
Thin.
It's very thin, yeah, it tends to run very easily. A lot of times when we think about, we see pictures or video of the lava flowing down through channels, that's typically going to be a basaltic magma. Okay, very low in silica. And again, a perfect example of this would be Mauna Loa in the state of Hawaii. So let's model that real quick.
yes.
Right here, that's what we call a cinder cone. So cinder cones tend to be very short,